Good day, guys. So today we'll be looking at the topic redox. So I believe if you're watching this video, you've watched the video I did on oxidation, and if you haven't watched the video I did on oxidation, I will drop the link on the description box. So ensure you check the video out on oxidation number and watch it. So because oxidation number of knowledge is quite usable here and is very essential in solving redox reaction. So redox reaction is a two simple word. So the red comes from the word reduction, and the word ox means oxidation. I repeat again, the word red means reduction and the word ox means oxidation. Now you can see from this illustration, oxidation and reduction speak that we occur together simultaneously. So they occur together simultaneously. So it is quite very useful and very essential to explain that the word redox, that is made up of reduction and oxidation. So reduction and oxidation occur together simultaneously. So it simply means that both of them occur at the same time. As reduction is occurring, oxidation is occurring. So they both have to occur at the same time, and this will help us in solving some questions. Because once you know that reduction is occurring with oxidation, it will help you to get some answer easily in some questions. So, however, they both deal with the transfer of electron within themselves. But however, the scope of redox is quite beyond or electron transfer. So redox can be explained in many ways, using oxidation number, using oxygen, using hydrogen, using electronegative element, and using electrons. So that's what we want to look at. So like I do used to say, like redox and redox reaction, which comprise of oxidation and reduction. So in the whole process of this lesson, so we'll be looking at the word oxidation and reduction. Now, it is very good that you should understand that oxidation and reduction, they are occurring at the same time, but they are not the same thing. They are opposite of themselves. They are simply opposite of themselves. So it is very good and very essential you know that they are not the same thing. So once you know oxidation, just know that the opposite of it is reduction. Once you know oxidation, the opposite become reduction. So let's look at it. So what is the meaning of oxidation? So oxidation number can simply be defined in almost 6 ways. So if I'm right, this should be approximately 6 ways. Then one, the two, the three, the four, okay, the five, and the six exactly. So the first one talks about that oxidation. So from the word oxidation or oxidation, so it loves oxidation number. So it is happy whenever oxidation number is increasing. So oxidation is the increase in oxidation number. So from what I told you, that the reduction is the opposite of oxidation number. So if oxidation number is a girl, then reduction will be a what? Will be a boy. So the same thing here, that if oxidation number is the increase in if oxidation is the increase in oxidation number, then reduction will be what? Decrease in oxidation number. So what I always tell students is that don't waste your time trying to know reduction. So what I will tell you is that once you know oxidation, just take the opposite of it for reduction. Once you know oxidation, opposite of it is reduction. So if oxidation is the increase in oxidation number, then reduction is the decrease in oxidation number. Now from the word oxy, it loves oxygen as well. So it is the addition of oxygen. So it is the addition of oxygen. So it simply means that reduction is the loss of oxygen. Now, so oxidation has already been in love with a particular element, which is oxygen, so it cannot love hydrogen again. So it is the loss of hydrogen. So while reduction is the gain of hydrogen. Now let's look at it. So far we know that oxidation loves it loves increasing oxidation number. So let's look at it. For example, in sodium has total electron of 281. But however, when sodium is studied alone, the oxidation number is 0. So when sodium becomes Na plus, the oxidation number become what? Plus 1. And how does that happen? Plus means that it has lost how many? 1. So sodium has lost 1 electron. It has lost this one in this process. So if the oxidation number increase from 0 to plus 1, from 0 to plus 1, that is increase in oxidation number. So here the oxidation number is 0, here it is plus 1. So it increase, and increase in oxidation number It's simply called what? It is called oxidation. Now, so if 0 to plus 1, then it simply means that the electron number will also decrease from 281 to 28. So it simply means that the decrease in electron or loss of electron is called oxidation. So oxidation does not just end there. Oxidation, it is the gain of electronegative element and it is the loss. So if it's gaining electronegative element, it means it doesn't like electropositive. So it's the loss of electropositive element. Another hint to understand this is to know the difference between oxygen and hydrogen. So don't forget that oxygen is an electronegative element, and as a matter of fact, the most electronegative element in the whole world is fluorine. And after fluorine, so fluorine is the first, oxygen is the second, and nitrogen is the third. So that tells us that oxygen is the electronegative element. So if oxidation is the addition of electronegative or is the addition of oxygen, so oxygen is electronegative element. So is this particular phrase is the same thing as saying that it is the gain of electronegative element. Why? It's still another way of saying that it's the gain of oxygen. And what is oxygen? Oxygen is the electronegative element. Now look at it. It is the loss of electropositive element. Look at it. If oxygen is to form ion, it will form O minus. So it means it's electronegative element. If hydrogen is to form ion, it will form H plus. It is electropositive element. So if it does not like hydrogen, then it can love electropositive element. And if it likes oxygen, it will like electronegative element. So from here, we have seen the six reasons or way by which we can explain oxidation. We have explained oxidation in terms of increase in oxidation number, in terms of oxygen, which is addition of oxygen, in terms of hydrogen, the loss of hydrogen, in terms of electron, the loss of electron, the gain of electronegative element, and the loss of electropositive element. So redox reaction is a story. I don't know, but I can tell you it is a story. So redox is a story. What did I mean by telling you that redox is a story? Yes, because for every story there have to be a beginning, and the beginning must have end. So the same thing in redox reaction. So the beginning of every reaction is the reactant side, and every reactant must yield a product, which is their end. So that's it in redox reaction. So redox reaction begins with a reactant and end with a product, just like any other reaction. Okay, but however, I need you to note some little things I will be saying in redox reaction. So let's look at an example 1 to signify in redox. An example 1. So let's look at this reaction, the reaction between zinc and hydrogen chloride to give zinc Cl2 plus H2. So here it is 2. Now, I need your attention. Now, you will see that in this particular reaction, to you, it may just look like a reaction. It is a redox reaction. Note, any reaction in which there is increase in oxidation number or decrease in oxidation number is automatically a redox reaction. How did I know this? So let's look at this particular reaction. Here, zinc is standing alone. If you have if you have watched the video I did on oxidation number, please, if you don't watch the video, or you don't understand what oxidation number means, you can't understand it. So you have to go back and watch the oxidation number. So one of the rules of the oxidation rule said that when a compound is standing alone, its oxidation number is 0. So here, so hydrogen in this type of compound, it is plus 1. So chlorine is an attached element. My advice is that never worry about an attached element, because oxidation number of an attached element, you can see chlorine is attached to hydrogen stand alone. So zinc collect the chlorine, so both of them are fighting over chlorine, so you don't need to worry about chlorine. Now focus on zinc. Zinc here, it is plus 2, and chlorine here, so I told you not to worry about that. But if you have to calculate for chlorine, in each cases it is minus 1. So far it is equal. That's the reason why we don't always pay respect to chlorine. So now hydrogen here, because hydrogen is standing alone, just like zinc here, is going to be 0. So zinc is 0 here, it is plus 2. So hydrogen is plus 1 here, it is 0. Now I need your attention, because why? You really need to understand this. Redox reaction is very simple to the extent that you can solve it in many ways. Now, number one thing you need to understand in redox is that anytime you see a redox reaction, number one, so you need to you need to find a way to find a product. So number one thing you need to find to solve a redox reaction is, number one, find the process. So the number one thing you need to do is to find the process. And what do I mean by the process? That is, you have to know whether the species is undergoing oxidation or reduction. So that is the first thing you need to do. So you need to understand the process. Now look at zinc. Don't forget, I told you the reactant side represents the beginning, the product side represents the ending. So this is my reactant. Reactant is always your left hand side, and the product is always the right hand side. So the first thing I will do is to understand the process. And what do I mean by this process? Now, if you are to look at this, zinc move from oxidation number of 0, it migrates to the oxidation number of 2. So if you are to look at your number line, the number line from 0 to +1, so to +2 and +3, so -1, -2 and -3, you will see that 1 is greater than 0, because it is always like this. So 1 is greater than 0. So from here, that will tell us that zinc increased from 0 to +2, and as you can see from here, the increase in oxidation number is called reduction. So it's called reduction. Then, so it simply means that this side, so zinc is undergoing oxidation process. So this is the number one thing you need to know. Number one is that you need to know the process. Now automatically, look at it, if one is undergoing oxidation, then automatically the other one will undergo reduction. So take note of that. The other one will undergo reduction. So that is how you need to know. Now, there are many things I need you to note. And this is how you know redox reaction. So number one thing you need to know is that number one is that the product in redox reaction is just only there to so the product is just only there. So please, everything I'm writing, ensure you're writing it. The product is just only there to give the end of the reaction. So to give the end of the reaction. So in another word, that is, the product helps in determining the process, whether it is oxidation or reduction. Now look at it. I wouldn't have known, assuming this product side is not there, I wouldn't have known whether zinc that is 0 later become +2, or hydrogen chloride that is or hydrogen that is +1 later becomes 0. So it is very, very essential you understand. So anytime I'm seeing a redox reaction, the first thing I need to do is to look at the reactant side and the product side, because the product side is communicating something big. The product side tell us what happened at the end of the reaction. The product side is a story completer. That's the reason why I said that redox is a story. So redox tell us, look at it, we can simply represent this with another thing. So let's use a play with method to explain this. Now look at we can use many ways to explain this. Now look at zinc. Zinc from the beginning of his life, so don't forget that the reactant side is the beginning. So zinc from the beginning of his life does not have a car. So let the C of chlorine stand for car. So zinc does not have a car, and at the end of the day, zinc has a car. You can see that hydrogen has a car, and at the end of the day, hydrogen does not have a car again. So you can see it helps us to know. Now let's look at it. Don't forget that chlorine is an electronegative element. Now note, if you are convinced, all non-metals are electronegative elements. How did I know this? That's the reason why I told you to go and watch the video on the oxidation number. If you watch the video, I did something like this. I did hydrogen, helium, then I did something like this: lithium, the beryllium, the boron, carbon, nitrogen, oxygen, the fluorine, the neon, the sodium, the magnesium, the aluminium, the silicon, the phosphorus, the sulfur, the chlorine, the argon, the potassium, and the calcium. Now these group 1, 2, 3, they are metals, okay, and these like this, so they are non-metals. So anytime I have all these non-metals, they are automatically electronegative elements, and these are electropositive elements. So take note of that. So but if you have watched the video, I believe it should be hard for you, because I believe I've explained all this in the video already. So let's move. Now, so from here we have seen that zinc does not have a car, and at the end of the day zinc has a car. So it means that zinc gain itself with the electronegative element. So chlorine is a non-metal. So you can see zinc does not have a non-metal. At the end of the day, zinc has a non-metal. Zinc, another way, zinc does not have a car. At the end of the day, it has a car. Another way to see it is that zinc does not have electronegative element. At the end of the day, zinc has electronegative element. So you see, the product is what you will use to determine the process. So what can you say about zinc? Zinc gain electronegative element. And what is the gaining of electronegative element? The gaining of electronegative element or the addition of electronegative elements. Can you see the gain of electronegative element is what? Is oxidation. So that's the reason why I said oxidation. So you see, for every redox reaction, at least you must have like 3 reasons that will back it up. Now you can see the number 1 reason I said that because zinc moved from 0 to +2, I said is oxidation. But let's say I don't want to use that. I can also say that because zinc gain electronegative element is also what? Oxidation, because oxidation is the gain of electronegative element. Now look at hydrogen chloride. Hydrogen chloride lost electronegative element. Hydrogen chloride has chlorine at this particular place, which is the electronegative element, but at the end of the day it lost the electronegative element, and the loss of the electronegative element will be what? Will be reduction, because I've told you if the oxidation is the gain, then reduction will be opposite of it. So reduction is the loss of electronegative elements. So I hope it's clear to you now. So that's to tell you that the redox is a story. Now take note of this. So in determining of anything in redox, so the answer should never be the product. So the answer should never be the product. It simply means that what I really want to say here is that if they ask you to find anything or determine anything in redox, so the answer should never be the product. And what are those things that you can be asked to determine in redox? So that's what we want to look at now. What are the things you can be asked to discover in redox? Number 1, they can ask you that which species. So these are the questions you should be expecting. They can ask that which species is reduced. So they can ask you that which species is reduced. They can ask that which species is oxidized. They can ask you that which species is the oxidizing agent. I'll be explaining this. You can ask that which species is oxidizing agent. Oxidizing agent means oxidant. So they can also say oxidant. So it's still the same thing. They can ask you that which species, which species is the reducing agent. So another word for reducing agent is called reductant. So it simply means that these are the 4 questions you should be expecting under redox. They will ask you which one is reduced, which one is oxidized. So they can ask that which one is oxidizing agent or which one is the oxidant. They can also ask you that which one is the reducing agent, which one is the reductant. So now let's look at it this way. So let's rewrite the equation back so that we can really flow along with it this time around and understand it better. Now, in the equation we have zinc reacting with 2HCl to give zinc chloride plus H2. Now, we have seen that zinc becomes it becomes zinc chloride, and what can we say? It moved from 0 to what? +2. That's the increase in oxidation number. So that is oxidation. Or we can say that because zinc gain electronegative element, which is chlorine, so that is what? Oxidation. So I hope that is clear to you. Now, but hydrogen chloride has electronegative element, and at the end of the day it lost the electronegative element. That is what? Reduction. Or we can say that hydrogen here is +1 and here it is 0. Reducing oxidation number is called zero. Reducing oxidation number is called reduction rather. So now, pay attention. Any species that undergo oxidation is automatically reducing agent. Please note the interchange of name. If a species undergo oxidation, the species is not an oxidizing agent, okay? If a species undergo reduction, the species is not a reducing agent, but it will be opposite of it. So it is what? Oxidizing agent. So now we want to look at meaning the interchange of this name. I hope you get my point now. That's what we want to look at. We want to look at the interchange of this name. Okay, now look at it. So please know the interchange of name: oxidation, reducing agent; reduction, oxidizing agent. Now note that if you want to find anything, whether oxidizing agent, whether you want to find reducing agent, whether you want to find which species is oxidized, whether you want to find which species is reduced, please, everything is only found at the reactant side. Everything is only found at the reactant side. The product side is just meant to tell us the story. The product is just to add meaning to it. The product is only adding meaning to it because if not for the product, we won't know what happened to zinc at the end of the day. We won't know that zinc later gained the chlorine, and we won't know that hydrogen chloride later lost the chlorine. I hope you're getting my point, please. So if they ask oxidizing agent and reducing agent, so look at it. For example, let's say in this question now they ask that which one is the oxidizing agent. They add zinc, and A is zinc, B is HCl, and C is zinc chloride, and D it is H2. Now, number one is that I will file out all my products because my product does not contribute anything to a redox reaction. Your product is just a story completer. Your product is just to add a meaning to your redox reaction. So number one is that I will clean away H2 because it's a product. So it's never meant to be there. I will clean away what? Zinc chloride, because it's a what? Is a product. So product does not add to your answer. Your product side will never be your oxidizing agent. It will never be your reducing agent. It will never be your reduced or oxidized. Is that clear to you now? So the answer always lies between your reactants. So, and we have only two reactants, either zinc or what? ACl. But even without teaching you, so the oxidizing agent from what I just did here should be what? ACl. All right. So now let's look at this reaction. So, and look at the meaningful thing. So if you want to write it, so feel free to pause the video and write it. So now from here, let's now look at it why there is interchange of name. But before that, let's quickly explain little things. For example, if they say that something is polluting agent, if they say that something is polluting agent, or if we assume that something is a polluting agent, then polluting agent is anything capable of causing what? Capable of causing pollution. Anything capable of causing pollution. Then if a substance is oxidizing agent, if a substance is an oxidizing agent, so it means anything capable of causing oxidation. Then if something is a reducing agent, anything capable of causing reduction. So that's it. Now write this down. So we need this. Write this down. So write it down that oxidizing agent is a chemical species. Which makes, is oxidizing agent, so it will make oxidation to occur. So is a chemical species which makes oxidation to occur and becomes what? Reduced. It becomes reduced at the end of the day. Notice this place, take note of the year. Become reduced at the end of the day. So the next one is reducing agent is a chemical species, so which makes reduction. So reducing agent will make reduction, which makes reduction to occur and becomes oxidized. So take note of this place as well. So now from here you can see that oxidizing agent is a chemical species which makes oxidation to occur. Oxidizing agent makes oxidation to occur and it becomes reduced at the end of the day. So I will explain this very well. Now that's to tell us that if ACl is an oxidizing agent from this particular reaction, why? Is because anything that undergo reduction is an oxidizing agent, anything that undergo oxidation is a reducing agent. Now, if ACl is an oxidizing agent, and at the end of it passes towards reduction, right? Then is the one that is reduced. You look at it, reduced is a past tense of reduction. So anything that passed through a reduction, after many times we say that that thing has become reduced. If a substance passed through oxidation process, then we say that this thing has been oxidized. So if something is oxidized, it means that thing passed through oxidation. If a substance is reduced, it means that the substance passed through reduction. So if a substance passed through a reduction process, is said to be what? It is said to be reduced. If a substance passed through oxidation process, is said to be oxidized. I hope it's clear to you. So from here, now let's now look at the interchange of name. Okay, but the most important to notice is that, like, oxidizing agent, can you see now, is a chemical species that makes oxidation to occur. Yes, as you can see, is the same one that will pass through, is the same oxidizing agent that will pass through reduction and be what? Become reduced. Now, a reducing agent is the one that make reduction to occur, and is the same one that will pass through oxidation and become what? Oxidized. Now let's now look at how the name change. It is very important we know how the name change so that we will never forget it. Now let's look at it. So we have zinc reacting with ACl. Now look at it. At the end of the day, they give this product zinc chloride plus what? H2. Now, it is very quite noticeable and to know this, that HCl will have been from the beginning of the reaction and even at the end and remain the same if not that zinc is there. Now, you will really understand this, or you will appreciate what I'm explaining, if you understand the mechanism behind this reaction. So the mechanism behind this reaction is simply the electrochemical series. And if you can recall from the electrochemical series, that we have what? Potassium, we have the sodium, the magnesium, the aluminium, the zinc, we have the iron, tin, lead, iron, tin, lead, we have hydrogen, we have the copper, we have the Hg, which is mercury, we have the Ag, and we have the Au. Now, from the electrochemical series, now it is quite noticeable that what? Zinc is higher than what? Hydrogen. So zinc is capable of separating or collecting chlorine away from hydrogen. So what happened here is that zinc sent hydrogen out of the solution. Now look at it. So it's to tell us that hydrogen wouldn't have lost chlorine if not for the presence of zinc. So the presence of zinc makes hydrogen chloride to lose this precious chlorine, and the loss of chlorine is called what? Is the loss of electronegative element, and the loss of electronegative element is called what? Oxidation. The loss of electronegative element is called reduction. Please, you can see from here, oxidation is the gain of electronegative element. So reduction is the loss of electronegative element. Now, back to my word. So I'm trying to explain that ACl wouldn't have lost the chlorine if not for the presence of zinc, which is greater than hydrogen. So the presence of zinc separates these two couples. So you can see from here, hydrogen and chlorine combine together to form a chlorine gas. So their union, which is hydrogen chloride, wouldn't have lost the chlorine if not for the presence of zinc. So the presence of zinc causes the loss of electronegative element, and the loss of electronegative element is called reduction. So the presence of zinc causes the loss of electronegative element. It simply means that the presence of zinc causes reduction. So if zinc causes reduction, that's to tell us that zinc is a reducing what? Agent. Because why? It causes reduction. It causes ACl to lose electronegative element. So it causes the loss of electronegative element. It simply means it causes what? It causes reduction. Is that clear to you? Now, let's look at how ACl2 becomes an oxidizing agent. So ACl is an oxidizing agent. Why? It's because, look at it, ACl, if not for ACl that donates this chlorine, will there be addition of zinc with chlorine? No. So if not that ACl has this chlorine, zinc wouldn't have gotten chlorine to form zinc chloride at the end of the day. So it simply means that ACl is the one responsible for the addition of chlorine to zinc. And addition of chlorine is called what? Is the addition of electronegative. And the addition of electronegative element is what? Is oxidation. So ACl is the one responsible for oxidation. So because of that, ACl is an oxidizing agent. So you can see now how the interchange of name happens. So they help themselves. Redox reaction enters themselves, they help themselves in achieving a common goal. Now at the end of the day, so let's now try to solve some little question related to this particular work we are solving. So it forms a zinc chloride, still the same equation, nothing different. Now from here now, so we have seen that zinc undergo oxidation, so it becomes zinc chloride, and ACl undergo reduction. And I've told you anything that undergo reduction is automatically a oxidizing agent, and anything that undergo oxidation is automatically a reducing agent. So imagine a question asks that which one is reduced. So the reduced species now, so what is the reduced species? The reduced species is the one that undergo reduction. So that is what I've told you. Never take your answer from the product side, okay? So your answer is between this and this. So the reduced species is what? HCl. Please, it's not hydrogen, HCl. So the oxidized species, it means the one that passed through what? Oxidation. So that is what? Zinc. So the oxidizing agent, which one is the oxidizing agent? Can you see it? ACl. So the reducing agent is what? Is zinc. Now can you see that my product is never found in my answer? So let's just look at one more or two examples, then that's all for this. And I will do a video on half cell equation, then from there to a complex equation, and that's everything about redox. Then after that, electrolysis. Now let's look at this particular reaction from copper oxide, that's copper 2 oxide plus carbon 2 oxide, to give carbon dioxide or carbon 4 oxide plus copper. Now in this type of reaction, so you need to understand how the oxidation number flows as well, or you can understand in many ways. I've told you redox is very sweet, that you can use many ways to understand it. Now I can say that copper has oxygen and copper does not have oxygen again. It has oxygen here and it does not have oxygen here again. So copper loses oxygen. The loss of oxygen is called what? Is reduction, because oxidation is the addition of oxygen, then reduction is the loss of oxygen. So it means that this is what? Reduction. So you can see my reason for saying it is reduction, because why? Copper from beginning. So the product helps us to know the process. I've said this several times. So if not for the product, I will know that copper later lost the oxygen. So the product is the one that contributes to the story, that makes the story interesting. Now look at CO. CO does not have oxygen. I mean, it only have one oxygen. At the end of the day, it has two. So it means that oxygen is more added, and the addition of oxygen is called oxidation. So oxygen is more added. Now another way to understand this, so like I told you rather, that redox has many reasons. It has many reasons. Now look at it. Here it is copper 2, right? Copper 2, so it means it's plus 2 here. Here copper is standing alone, the oxidation number is 0. So when the oxidation number move from, can you see, if the oxidation number move from plus 2 to 0, it means it's decrease, and the decrease in oxidation number is what? Reduction. Have you seen another reason? Now here, this is carbon 2 oxide, carbon 2 oxide. So here it is 2. This is carbon 4 oxide. So the oxidation number increased from 2 to 4. The increase in oxidation number is called oxidation. Now, so from what I just explained to you of recent, that any product that undergo reduction is what? Is an oxidizing agent. It undergo oxidation, it becomes a reducing agent. So from this answer now, from this question, so our reducing agent is what? Is CO. Our oxidizing agent is what? Is copper oxide. So if they ask which one is reduced, so which one is reduced from here, it means which one undergo reduction, that is copper oxide. Which one is oxidized, that is which one undergo oxidation, that is what? CO. So let's look at one more example. So one more example is H2 plus Cl2 to give HCl. Now look at this reaction. So it is very interesting. Yeah, I love this because they have the same ending, like the ending looks very familiar. So now here hydrogen is 0, but here hydrogen is plus 1. If you don't understand how I'm getting this error and plus 1, go and watch the video on oxidation number. So here chlorine is 0, here chlorine is minus 1. Now look at it. Hydrogen moved from 0 to plus 1. Is that not increasing? Yes, it is increasing. So hydrogen undergo oxidation. So it means anything undergo oxidation become a what? A reducing what? Agent. What an opposite. And chlorine is 0 and it become minus 1. It means that is lower. So minus 1 is lower than 0. So it means that the oxidation number reduced, and the reducing oxidation number is called reduction. So that's tell us that so anything that undergo reduction is an oxidizing agent. So for this particular answer, our reducing agent is what? H2. You can see that all my answers are gotten from the reactant side. So my oxidation, my oxidizing agent is chlorine gas. My species that is oxidized, so the species that is oxidized is what? So oxidized means which one undergo oxidation? H2. And which one is reduced? It means reduced means which one undergo reduction? That's chlorine gas. Now the most important thing to note, so now that you know how to find oxidizing agent and reducing agent, so this is very essential for JAM students. Okay, let me just give you one more. So before we move on to another word, so let's say we have copper 2 plus zinc to give zinc 2 plus copper. Now you need to understand the flow as well. So it is very simple. The oxidation number of copper here is plus 2. Oxidation number of copper here, copper is standing alone, so it is 0. So oxidation number of zinc here is standing alone, so it is 0. Oxidation number of zinc, it is the charge. So you can see their charge is the oxidation number. That's the secret. So oxidation number of zinc here is plus 2. Now look at it. Copper moved from plus 2 to what? To 0. So it means that at the beginning it is plus 2, at the end is 0. So it later decrease. So that is what? Reduction. The decrease in oxidation number is reduction. So zinc moved from 0 to plus 2. So that is increase in oxidation number. So this is what? Oxidation. So zinc is oxidized and become oxidation. Now anything that undergo oxidation become anything that undergo reduction become oxidizing agent. Anything that undergo oxidation become a reducing agent. I hope it's clear to you. And I've told you that the oxidizing agent is also called what? It's also called oxidant, and reducing agent is also called reductant. Now note, so there are some special reactions that are not reactions. So these are reactions that are not redox. So number one reaction that is not a redox is a neutralization reaction. So neutralization reaction is the reaction between acid and base. And a good example of acid is HCl, and a good example of a base is KOH, or sodium hydroxide is still the same. So here they will form KCl plus what? KCl and H2O. Now plus H2O. Now the question is, why did I say that it is not a redox reaction? So any reaction that is not a redox reaction, it means that the oxidation number will remain the same. It will not change, it will not decrease. Now look at hydrogen here. Hydrogen here is plus 1. So here it is plus 1. Does not change. Here too is this plus 1. It does not change. Chlorine is minus 1. Here chlorine is still minus 1. Potassium is plus 1. Here potassium is still plus 1. So here oxygen is minus 2. Here oxygen is still minus 2. So there is no change in electron. So no change in electron. And you can also calculate using net equation as well. Plus 1 plus minus 1, it has gone, right? So here we have plus 1, so that's 2. So plus 2 minus 2, that's 0. So this cancels this, so and so on. At the end of the day, you end up having the same thing. So no electron. So if the electron at one side, so the best way to understand this, and even without being confused about this, because we are still going to look at this anyway, so is that you need to look at it. A particular species, does oxidation number increase? No. For chlorine, does it increase? No. For oxygen, does it increase? No. Oxygen is minus 2, it's still minus 2. Potassium is plus 1, it's still plus 1. So no change. So no change in oxidation number. So it's not a redox reaction. So another one is precipitation reaction. So precipitation reaction is not a redox reaction. So it's the reaction between two ions. So ion plus ion to give a solid that is insoluble. So that's the meaning of precipitation reaction. Example of such an ion is silver plus chloride ion. So to produce silver chloride, which is insoluble. So now look at it. So from here, Here, the oxidation number of sliver is the valency, that is +1. Of chlorine is valency -1. So in this compound too, sliver is still +1. In this compound, chlorine is still -1. So you can see the oxidation number is still the same. It's still the same. So no net equation, or let's say that no net electron. So it simply means that the electron is the same. So it is not the redox reaction. So I believe at the end of this particular video, you can solve any question on the redox reaction. So our next topic now will be solving of half cell equation under redox reaction. Thank you so much for your time.